Hello friend, today we are going to look at DC circuit analysis, and we have got a question that is going to guide us. The question says state superposition principle. Part B of it says for the circuit given below, calculate the current through the 16 ohm resistor using superposition. So this is the circuit given, and this is the battery E1 giving us 20 volt, E2 giving us 30 volts, 4 ohm is resistor R1, 24 ohm resistor R2, and 16 ohm resistor R3, and these are nodes A and B. So let us directly go to answer this particular question. So this is part A. Superposition theorem states that in any network made up of linear resistances and containing more than one source of EMF, the resultant current flowing in any branch is the algebraic sum of the currents that would flow in that branch if each source was considered separately, all other sources being replaced at that time by their respective internal resistances. It means that the voltage sources are going to be short-circuited, whereas the current sources are going to be open-circuited. Now for us, just to summarize it all, let us take these notes on how to apply superposition principle. One is you retain one source at a time in the circuit and replace all the other sources with their internal resistances. 2, you determine the output current or voltage due to the single source acting alone using any circuit analysis techniques. You can use mesh, node transformations with, of course, the application of KCL and KVL. Or the Kirchoffs laws should also be used amidst these analysis techniques. Number 3, repeat steps 1 and 2 for every independent source. Find the total contribution by adding algebraically all the contributions due to all the independent sources. So if required to calculate the current in one particular ohm, then you would consider the independent sources separately, then their effects or their contributions in terms of currents will be algebraically summed up to gain the final answer of the current that would flow. Now, if we are to solve part B using superposition, let us consider the 20 volt source only and replace the 30 volt source with a short circuit. This is the 20 volt, 4 ohm, so the 30 ohm has been short circuit. Now if we consider IS prime, single prime, to be the current produced by 20 volt source and passing through 4 ohm, so when it reaches at A, it divides into current that will flow in 24, I24 prime, and through 16 ohm resistor is I16. If I consider this to be a loop 1 and this one to be loop 2, then it means if we use mesh analysis and we apply KVL to loop 1, it means this will be 20 volts. This is a plus, so we take a plus, then minus. For I, because it comes out when it is a minus, then minus 16. For this particular loop, current is flowing like this, so minus 16 ohm resistor times I16. Therefore, let us use KCL also at node A, the current Kirchoffs current law. So IS single prime is equal to the sum. In other words, current entering this node is equal to the sum of currents leaving that particular node. Therefore, from that law, I16 single prime is equal to IS minus I24. So if we substitute equation 2 in equation 1, this is equation 1, this is equation 2, it would give us 20 minus 4IS minus 16 into IS minus I24. Simplifying this one, minus 20 IS plus 16, that one would give us negative 20 is single prime plus 16 I24 single prime is equal to negative 20. Now let us apply also KVL to loop 2. If we apply KVL to loop 2, it means if we consider this 24 ohms resistor, when current flows through it, it will come with a minus. So it will be minus 24. Then we continue and say now plus, because it enters here through negative, comes out positive. So we shall say plus now 16 times I16. So, but we already know the value of I16. So when we substitute in, and the total voltage is equal to 0. Therefore, it means if we summarize that statement, it will be minus 24 I24 plus 16 is minus I24, because this itself is I. So this is equal to 0. Simplifying this would give us minus 40 I24 plus 16 I is equal to 0. So is single prime will equal to 5 out of 2 I24. Therefore, this is equation 4. This is equation 3. We are going to solve, of course, simultaneously, and we are going to use by substitution. So from equation 3 and 4, we can substitute equation 4 in 3, so that we get this equation minus 20 into is, which will be 5 over 2 I24 plus 16 I24, which is equal to negative 20. So this is by 2 10 by 2 1, so this becomes negative 50 I24 plus that I24, and this would give negative 34, and the answer would be 0.5882 amps. These negatives will go. So the assumed direction of current I24 is right. From equation 4, also is equal to 5 out of 2 times I24. So when we substitute in 0.588 times 5 out of 2, this would give us 1.471. Therefore, the assumed direction for current is right. When you proceed, I16 therefore will equal to is minus I24, which would be 1.471 minus 0.5882, and this would give us also 0.882 amps. The assumed direction of I16 is down, so the direction for current I16 is down. That's why we draw that arrow facing down. Since is contributed by 20 is also the same as the current passing through the resistor 4 ohm, then is equal to I4, and therefore it is equal to 1.471. Now, those are the currents contributed by source 20 volts. Let us consider the scenario when the 30 volt source is on and the 20 volt source eliminated. Still, from loop 1, when we consider loop 1, let us apply. We are considering the fact that the current is flowing from the 30 volts like this. So in this particular direction, we are considering loop 1 to be this way and loop 2 here. So that if we apply KVL, currents, Kirchoffs voltage law, minus 4I, because it is entering positive, leaving a negative. So we shall take a minus 4I double prime 4 plus 16I double prime, then it is equal to 0 here, because we are saying this one is flowing in a negative direction, so it will flow through -1 and comes back when it is a positive. That's why we are adding. Okay, so from current, from Kirchoffs current law, let us apply it at node A, so that current entering into A is equal to the sum of currents leaving, meaning that I16 double prime is therefore equal to is double prime minus I4 double prime. When we substitute it in here, it means minus 4I double prime 4 plus 16 is minus I4 will equal to 0, and it shall give us 16 is equal to 20 I4. So is is equal to 20 out of 16, and of course by 8 we get, by 4 we get 5, and by 4 we get 4 here. So that we have is double prime equal to 5 out of 4 I4. Let us consider loop 2. When we consider loop 2 and apply KVL or Kirchoffs voltage law to loop 2, current is assumed to be moving in this particular direction. So it means it is leaving a positive, so 30 V 30 minus 24, because it is leaving negative, leaving 24 when it is negative, so minus 24 is the current flowing through it. Then again minus the current flowing through the 16 ohm is leaving when it is negative, so minus 16 I16. So we know I16 as is minus I4, so when we substitute in and simplify, this would give us negative 40 is double prime plus 16 I4 double prime is equal to negative 30. The double prime just is to differentiate between the current contributed by the 20 volt source and the current contributed by a 30 volt source. So from equation 5, this is equation 5 and equation 6. So we substitute equation 5 in equation 6, and this would give us negative 40 into 5 out of 4 I4 double prime plus 16 I4 double prime, giving you negative 30. When we simplify and solve this equation, it gives us I4 equivalent to 30 out of 34, and this gives us 0.882 amps, meaning that the current passing through the 4 ohm resistor as assumed to be is right, so it is flowing to the right. Is, because the current flowing through current from the 30 volt source is equal to 5 out of 4 times I4. So since I4 we know it as 0.882, we just substitute in and get Is, the current flowing through the 30 ohm resist, the 30 volt source, to be 1.103 amps. What about the current flowing through the 16 ohm? Is going to be Is minus I4 as according to the above equation. Then it would give you 0.221 amps, and it is also flowing down. So if we apply superposition such that now we algebraically sum up the effects or the currents contributed by the different sources, then the current flowing through the 4 ohm resistor is equal to 1.471 plus 0.88. So this one is to the right, this is to the left. So if I take the right to be positive, then it will be 1.47 minus 0.8. Actually, it is 1.471 minus 0.882, and this would give us 0.589 amps, and to the right. What about current flowing through the 16 ohm resistor? It is 16 I16 single prime flowing downwards plus 16 I16 double prime flowing downwards. So we just sum up 0.882 plus 0.221, and this would give us 1.103 amps. So I solved this using a particular software called Multism, and our values are right. Thank you so much for watching. Follow us in our next lecture.